Hello, Earth Science class. So welcome to my secondary video studio, also known as my bedroom. I have a nice blank wall here. So today we're talking about the experimental method. If you guys haven't checked out some of the CK12 readings I've posted on today's agenda, you might go ahead and do that. You can always pause this video and come back later. The experimental method is basically about how scientists get things done. And basically it kind of outlines what they do. It always starts with a question or a problem about nature or technology. For example, why do things fall to the ground? That's a great question to ask. Um, how does a car work? Or how can we make cars perform more efficiently? So all these are questions, and whenever scientists want to tackle these questions, they use the experimental method. We're starting with the experimental method, not only because it's common in every science class you're going to find, but also because there's going to be lots of facts thrown at you at Earth Science. Earth Science is great because we get to learn about so many things, so many tangible things, some things that you can actually go home and find and look at yourselves or look up in the sky and see. But lots of facts are going to be thrown at you, and all of these facts were obtained through the experimental method. So whenever you hear me say something like, the earth is round, the sun is really big, much bigger than the earth, in fact, you don't take all these facts as true just because I said them. I want you guys to be curious and think about people actually had to verify these facts. I'm not sharing facts just because that's what I think the way things are. So let's go ahead and look at the slides I shared with you guys today. We're going to look at what the experimental method is and go over some examples of how we could use the experimental method ourselves. So the first step in the experimental method is that you always start with a question about nature or a problem that you have. And I talked about that already. The second step of the experimental method is research the problem. If I want to know how a car works, if my question is how does a car work, I could do a little research about cars to get some basic ideas about axles and tires and engines and all that sorts of things. Those sorts of things. Third step is to write a prediction. So if a car works this way, then I should expect this to happen. If A happens, then B should also happen. This is kind of a causality statement. A lot of people call number 3 a hypothesis, which is an educated guess. I kind of changed that a little bit to say a prediction, because that's what we really want to make. We don't want to just say it's a guess. If my question is how does a car work, then I can say, well, my educated guess is that dwarves are making the axles turn. That's kind of that's not really a very good. It's not. First of all, it's not really educated. Secondly, I could do a little bit better in making a prediction, something I can actually experiment on. Speaking of experiment, the next step is to actually test your prediction. Going to move my video down here. Test my prediction. So what are some ways I can test a prediction about, or how can I test my prediction? What experiment can I put to use? Then I gather data from my experiment, and then I would write some sort of reflection or conclusion. So these are the 6 major steps. You guys can read about them in the readings I assigned to you. Let's go ahead and look at examples instead of me just making one up off the top of my head. So here's the first example. You cook some plain scrambled eggs on the stove, but they taste pretty bland. I'm going to move my video back up here, excuse me. If you've ever cooked eggs just by themselves, you might not notice they don't taste too good except for that yummy yolk in the middle. Not too much taste to it. So what's our problem? That's the first step of this experimental method, is identifying some sort of problem or question. So our problem is that the eggs do not taste good. If we wanted to turn that into a question, we could say, well, how can I make my eggs taste good? Could we research the problem? Well, yeah, we could easily research the problem by if we just consult chefs or maybe just random people on the internet. You might find that butter or salt could add some flavor to scrambled eggs. Okay, so what kind of prediction can we make, or what is something that we can predict? So predictions are usually if-then statements. So if I add salt, then the eggs will taste good. So that's my prediction. I haven't done anything to the eggs yet, but that's just what I'm thinking. Whenever you sit down at the dinner table, it's like, this doesn't taste so good. As you're reaching for that salt shaker, you're already making a prediction in your head. If I add salt, then this is going to taste good. I hope. It doesn't work all the time, but most of the time it does. How can we test our prediction? Well, you add salt to the eggs, and then you compare the taste of the salted eggs to the unsalted eggs. That's basically our experiment right there. Whenever we test something, we're experimenting on it. Okay, and what data do we gather from the experiment? Well, the salted eggs taste better than unsalted eggs. That's our data, is that the taste has improved. And so what is the conclusion on the experiment? Well, eggs should be salted for good taste. So next time you take eggs off the stove, put some salt on it before you serve it. Okay, so that's one example there. That's just kind of, remember, experimental method doesn't have to be sciencey. We're going to talk about a lot of cool things we're going to find in nature, but so you can do science in the kitchen. There's so much science happens just in the kitchen of your home when you cook things and mix different substances together. You're doing lots of physical and chemical changes are happening right in your kitchen. So here's another example. When the Titanic sank, what happened to the water level on shore? So this is, let's kind of break down this problem here. Titanic, big boat, early 20th century, sank. When the Titanic, and so what this is asking is, well, after the Titanic sank under the water, what happened to the water level on shore? So the Titanic sank in the middle of the ocean. So I think it was heading to England. So what happened to the water level all the way in England when the Titanic sank? We kind of know intuitively that when you fill a bathtub and then you sit in the bathtub, the water level goes up because your body displaces some of that water. You're increasing the volume of the entire bathtub. So is the same true with the Titanic? When the Titanic was above water and it sank, does the water level rise on shore? Or is the size of the Titanic so insignificant to the rest of the ocean that the water level doesn't really change that much? Okay, so it's a valid question. So do some research on the problem. What causes water level to rise or fall? So again, that talks about volume and displacing and mass and gravity. There's lots of science that goes into what causes water to rise and fall. So maybe it might be a good idea to do some research before you actually try to do an experiment. But if you were going to make an experiment, you could say something, well, the water level rose. If something is submerged in water, then the water level should rise. Okay, that's a prediction you can make. Or you could say that, no, the water level is not going to rise, or the water level is actually going to go lower. Your prediction is what it is. Your prediction doesn't have to be correct. Even if you have an incorrect prediction, well, then you just go back to the third step and try a new prediction. Or there you go, the water level dropped, or the water level stayed the same. Okay. So then you could test your prediction by experimenting. So you could sink a toy boat or model boat in a bathtub and measure how the water height changes. So you make a marking, or measure how high the water is before the boat goes in, measure how high it is after it goes in. And then make that model bigger and bigger and bigger until you finally get to a Titanic, or you can make your model boat smaller and smaller and smaller. Remember, you're trying to model the size of the ocean compared to the size of the Titanic. So you might have to make some measurements. If you measure your bathtub, how big is your bathtub compared to the ocean? They might shrink down the Titanic accordingly. So a lot of consideration would go into that. A lot of consideration would go into, well, how does this work? How did the ocean waves play a factor in this? There could be a lot of things you need to consider when setting up your experiment. So, but by the end, you'd gather some data. Your data would be whatever water height level would be. Even though the problem can be a lot more complicated when you consider the size of the Titanic compared to the rest of the ocean, and then also consider ocean waves and wind speeds and rain level, all of that stuff. All that stuff might complicate your results, but your final data is still going back to the question, what happened to the height of the water? So your data is the height of the water. And your conclusion would also be based on that. Was your original prediction correct? If I said my prediction is water level rose and actually the water level sank, I was like, well, how's that work? Well, maybe the ocean is more dynamic than I would have thought. Maybe something about the iceberg breaking up into pieces would also have something to do with it. If by the time you get to number 6, if your prediction is not correct, you could go back and make a new prediction and say, well, because of this, the water level actually sank. And just by finishing this one experiment, I opened up a whole nother question on, well, what are the dynamics of the ocean compared to the dynamics of, say, maybe a bathtub? And that's the beautiful thing about the experimental method, is that once we finish one experiment, we usually open the door for 12 more experiments, which is why the field of science is a growing field. It's never we're never going to run out of questions about the universe. I hope we never do. So those are 2 examples of the experimental method. I hope this helps you understand what the experimental method is. Tomorrow, you're going to get a chance to put the experimental method to the test using just some simple supplies you have in your home with the paper folding challenge. Some of you guys might have already looked at the paper folding challenge already. Later this week, you're going to just kind of, as the quiz for this week, you're going to match up, well, what was my prediction in the paper folding challenge? What was my results? How did I get my data? What was the initial problem? So if you need help on the quiz, come back to this lecture, come back to this slideshow. Or if you can always contact me. All my contact information is going to be on Google Classroom. The quickest way to get a hold of me is usually text or email, but I'll take phone calls as well. And I hope you enjoyed class this week. I probably haven't, at this point, I probably will not have gotten a chance to meet a whole lot of you, but I look forward to getting that chance. And just to wrap up this video, hope you guys have a great day.